Hello Year 8, welcome to today's first lesson where we introduce trigonometry. So can you please write the title and the date. The title is Trigonometric Ratios and Calculating Missing Sides, and have a go at the do now task based around Pythagoras, which we've been doing recently. Please pause the video as you do this. Right, good. So the first one says a fireman has a ladder that is 13 metres long. So we can see that here, 13 metres long. And he wants to reach a window that is 12 metres above the ground, so it's 12 metres high. How far from the wall should he put the bottom of his ladder? So we're looking for this distance here. We know that's our right angle, so we know that's our hypotenuse. So again, we know we're looking for a smaller side, and therefore we're doing c squared minus a squared equals b squared. C is our 13, a is our 12, so we're doing 13 squared minus 12 squared to get this side squared. Okay, so now with 169 subtract 144, which is 25, and again, this is a question that could actually be on calculator because all these calculations you can do. A square root of 25 is 5, which means the distance of the foot of the ladder from the wall should be 5 metres exactly. Right, second one, Laura is buying a television. It has a 34-inch screen. If it is 16 inches tall, how wide is the screen? So what we're looking for here is this distance. Okay, there's our right angle, which again tells us that that's the hypotenuse. So again, we're looking for a short side question. So it's c squared minus a squared is b squared. That's our c squared, 34, and our a squared is 16. So we're doing 34 squared minus 16 squared to get b squared. So we get 900. And the square root of 900 is 30 exactly, which tells you that the television is 30 inches wide. So no, it won't fit in. Lovely. Right, so success criteria today. Bronze is to be able to label right angle triangles. It might sound silly, but it's really, really important that we can label all the sides and things. Silver is to understand what SOHCAHTOA means. That's really important. There are trigonometric ratios. And then gold is to use trigonometry to calculate a missing side, okay, to find a missing side. So we'll start by having a look at a right angle triangle. So I'd like to draw this first, and then we're going to look at how we label our three sides, how we know what they're called, because for trigonometry you need to know what they're called in order to be able to pick the correct calculation, of which there are three. Okay, sorry, the correct ratio. So we should know that's the hypotenuse because we know from Pythagoras the hypotenuse is opposite the right angle. That is the same, okay, it doesn't change. So opposite the right angle. Then we've got this side here that's opposite the other labelled angle. You see here there's no label there. Okay, there is a label here. It's shown, it's highlighted on the diagram, and we call that the opposite. So opposite the other labelled angle. And then last but not least, we've got this side called the adjacent. And the adjacent is where the side that both the right angle and the labelled other angle sit on. Okay, and it's the other side. So if you can identify the hypotenuse as being opposite the right angle, the opposite as being opposite the other given angle, the adjacent is just the other one. Okay, so please pause the video, copy down this diagram, and the definitions that are in the yellow boxes. Right, lovely, we'll go through a couple more examples together and then you'll have a go at sketching some triangles and then just labelling them effectively. So here, first things first, there's my right angle, so I know that's the hypotenuse. There's my other labelled angle, so the opposite side here is the opposite. And then the other side that the right angle and the angle fit on is my adjacent. Okay, if we have a look here, well, there's my right angle, so opposite is this side, that's my hypotenuse. We've got this angle labelled here, so opposite here, and then the other side is our adjacent. Okay, right, can you please sketch these three triangles in your book? And do sketch them, you don't need to get a protractor out to measure 90 degrees, just sketch them, label the right angle, label the other angle, just by shading it a little bit or labelling it as something, and then label the three sides for me, hypotenuse, adjacent or opposite, and please pause the video as you do this. Right, lovely, so for this first one here you should have hypotenuse, opposite, adjacent. For the second one, hypotenuse, opposite, adjacent, and then for the yellow one, hypotenuse, opposite, adjacent, and hypotenuse, opposite, adjacent. Okay, right, have another go at these questions for me, see if you can label all of the sides. Right, okay, good, let's have a little look. So we should have hypotenuse, opposite, adjacent, hypotenuse here opposite the right angle, opposite the other labelled angle, and adjacent, hypotenuse opposite adjacent, and hypotenuse opposite adjacent. Brilliant. Okay, now these are our three trigonometric ratios. Okay, and what I need you to do is to write down the ratio and the triangle that goes with it. So this idea here of sine theta, cos theta, and tan theta, that means the angle. So when you're trying to find the angle, you're using these particular sides to help you. So what I would like you to do is maybe write SOHCAHTOA, and then make sure you get these triangles down. And do you remember we did compound triangles before, when we looked at speed, distance, time, pressure, force, area? This means divide. So if you're looking for the hypotenuse, you do the opposite divided by sine, which is the angle. We'll look at that later. And then if you're looking for the opposite, you do a multiplication of the other two variables. So please get down these three triangles and SOHCAHTOA for me. Please pause the video as you do this. Right, lovely. Okay, so next thing. We're going to look at just being able to identify the correct ratio depending on what we're being asked to do. Okay, so sine matches up with SO. Okay, sine, that's what that S stands for. Cos matches up with Ca, so SO, Ca, and the cos, the C here, shows that it's this trigonometric ratio. And then we've got tan, which matches up with this trigonometric ratio because the letter T is there to tell us it's tan. Okay, now if we were trying to find an angle sine, okay, which trigonometric ratio will we use? Well, it will be this one here because this is our sine. Okay, and to find sine, you have to do opposite divided by hypotenuse. Okay, which in this case, the opposite is here because it's opposite the given angle. The hypotenuse is here because it's opposite the right angle, and then this is the adjacent. So you do opposite divided by hypotenuse, which is 3 divided by 5. For the next one, if we were trying to do cos, we would look at Ca. Okay, so we're trying to find our cos angle, so you would cover that up and you would do adjacent divided by hypotenuse, okay, which will be 4 divided by 5, or 4 over 5. Then we're going to look for tan angle. So we'd cover up the T and then we go, right, we do the opposite side over the adjacent side. Well, there's the opposite and there's the adjacent, so it will be 3 over 4. Let's look at another one. So triangle looks different, it's still a right angle triangle. So again, if we're doing sine, we should recognise now that that sine means SO. Okay, you should have these written, but if you don't, please do them. Okay, we're looking for sine, that's this bit here. Okay, so we need to do opposite divided by hypotenuse. Okay, we know for cos, we're doing adjacent divided by hypotenuse because we say Ca. Okay, and when we're doing tan, which looks like Toa, we're doing opposite over adjacent. Okay, so what I would like you to do is have a look at this triangle, sketch it and label the sides, and then complete the trigonometric ratios there for me. Pause the video as you do this. Good, so we should have opposite over hypotenuse, so you should have 5 as your opposite because opposite the other given angle. You should have 13 as your hypotenuse, and then 12 as your adjacent. Okay, so you should have 5 over 13. For cosine, it's adjacent over hypotenuse, so 12 over 13. And then the only other one is tan, so it's 5 over 12, opposite over adjacent. Lovely. Right, we'll have another go here. I would like you this time to complete them yourselves. So for sine, if I show you, remind you how to do the first one, you would put in, it's opposite over hypotenuse, because we know it's SO. Okay, so we're looking at sine, it's opposite over hypotenuse. What would that be? Well, let's label. We've got the opposite side here, we've got the hypotenuse side here, and the adjacent there. So SO includes the opposite and the hypotenuse, so it will be 9 over 41. Can you please pause the video and complete the other two trigonometric ratios? Thank you. Good, so you should have adjacent over hypotenuse and opposite over adjacent, and therefore 40 over 41 and 9 over 40. Please now have a go at this one completely independently. Please pause the video as you do this. Good. So you should have opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent, then 12 over 20, 16 over 20, and 12 over 16. Tremendous. Right, the next thing we're going to look at is how we can use trigonometry, so it's still SOHCAHTOA, okay, use trigonometry to calculate a missing length. Now with Pythagoras you can find a missing side length if you have the other two sides and it's a right angle, but we use trigonometry when we aren't given two sides. We use trigonometry when we're given an angle and a side. We can use it to find another side length. So the first thing I would do is I would label the things you have information for. So you've got an x here, so it's labelled. We know it's the opposite because it's opposite the 40 here, look. Okay, so it's opposite. We know this one's the hypotenuse opposite the right angle, so that therefore must be the adjacent. So we know we have opposite and adjacent. The trigonometric ratio that has the opposite and the adjacent included is tan, TOA. Okay, so we know which one we're using. Now what you have to do next is look here. So we have the opposite that we're looking for, so we can ignore that, and then we're using this. We're using tan times the adjacent. So in your calculator, write tan, then the bracket will appear, put 40 close bracket, that's your angle, times by 5. Okay, when you press equals, you will get 4.195 and so on. Okay, and then if you simplify that, so I don't simplify it, if you do it to one decimal place, you get 4.2 centimetres. Okay, right, we'll have a look at another one together, a couple together, and then you'll have a go at a couple on your own if needs be. So first things first, we need to work out which trigonometric ratio is it we're using. So let's label the sides where we have some information. So we've got an x there and an 8 there. So those two sides are the hypotenuse, because it's opposite the right angle, and the opposite. So which trigonometric ratio involves the hypotenuse and the opposite? Well, it's this one here, okay? It's sine, all right? Now, if we're trying to find the thing that's missing, so we're trying to find the hypotenuse, we're using opposite divided by sine, and sine is our angle. So in your calculator you can write it as a fraction, so fraction button 8, which is our opposite, divided by sine 30, or if you want to, you can write it like this. It's not a problem, it gets you to the same place. Then when you press the equals button, you will get opposite equals 16 centimetres. I'd like you to copy this example down, please. Pause the video as you do this. Right, good. Next one. So we'll do another teacher example together. So we have this example here. So let's label what we've got first. So we've got these two sides. We know it's a trig problem because we've got an angle, a side and a missing side. So we've got the adjacent here because it's where the right angle and the other angle lie. And we've got the opposite because it's opposite the 50-degree angle. So which trigonometric ratio uses opposite and adjacent? Well, it's tan. Okay, now because it's the adjacent we're looking for, let's cross him out, and we're going to do the opposite value, which is the 8, divided by tan angle. Okay, so we'll do 8 divided by tan 50, and again, similarly to the other one, there's nothing stopping you from writing it like this in your calculator if you don't want to use the the fraction button. You get to the same answer. In fact, you could test both. Then you get 6.712, but we know we can't write that long decimal, so let's round it to a sensible degree of accuracy, which will be 6.7 centimetres. Please pause the video and copy this example down. Good, we'll have a look at another one together. Actually, there might be one more as well. So let's label the sides that we've got. So we've got a label here because we've got a 12 and we've got a label here x. So we know that's what we're looking for. We know it's trig because there's an angle given. So if we label our sides, we know that's the adjacent because it's the side where the other angle and the right angle lie on, and we know that's the hypotenuse because it's opposite the right angle. So we're looking for the trigonometric ratio that involves the hypotenuse and the adjacent. Well, it's here, and it's the adjacent we're trying to find. So let's scribble him out. We're doing cos angle multiplied, because remember that's what that means, like our compound measure triangles, times the hypotenuse. So we can just write that like this, okay? Cos bracket 30 close bracket times 12, okay? If you put that into your calculator, what you then get is 10.392, which will round to a suitable degree of accuracy, which is 10.4 centimetres. Now, with these sorts of questions, as long as you remember this idea of toa, soccer toa, keep saying it to yourself. This trigonometry is really easy for finding these sides, because if you can remember what these triangles are, soccer toa, you'll know which one to use and you'll be able to label your diagram and find the answer. Okay, so we'll go through one more together. In fact, actually, if you pause the video and have a go at this one yourself before you do a large number of questions, to see if you can do it first. So pause the video, see if you can answer this question for me. Oh, there we go. Right, good. So hopefully you've already got the hypotenuse labelled there. We've got an angle given, so we know it's the opposite. So you should have gone, right, it's an hypotenuse and an opposite, so opposite hypotenuse. That's the one we're using. Okay, you might have gone, right, I'm looking for the hypotenuse, so I'll cross that out. So I'm doing the opposite over sine angle. Okay, so I'm doing 9 over sine 25, or some of you will have done this. Okay, and you'll get this answer here, and then you get 21.3. Okay, now if you, in fact I should have said this right at the start, on your calculator, I hope you've found those buttons. It's quite clear in the top set of numbers where sine, cos and tan are. So some of my groups, students in my groups in year 10 this year have asked me what those buttons are for, and I've said wait and see because they're for trigonometry. That's what they're for. Okay, so let's have a look now at some practice questions. I would like you to have a go at these 12 questions. Now these are nice and straightforward. These are our more straightforward questions, our lower level questions that we're just going to solidify our understanding, because it tells you which ratio to use. So it says use tan, it says use sine, and it says use cos. Okay, now you should have in front of you your 3 triangles. Okay, so you should have toa. Okay, for tan, you should have so, and then you should have ka. Okay, now what I would like you to do is find the missing sides. So for each one, sketch the triangle, label everything that you can. So label the 2 sides you're given, work out what you have to do with the triangle, and find those missing sides. Please pause the video as you do this. Right, lovely. First one, so you should have got 7 centimetres. Okay, because look, you're trying to find the opposite. So it's tan 41 times 8, or 8 times tan 41. For this one here, you should have 15.6. Now look, you're looking for the opposite again. So it's your multiplication of your tan angle and your adjacent. Here, you're trying to find the adjacent this time because that's the opposite. So if you're trying to find the adjacent, it's opposite 6.6 over tan 49. And then here again, you're trying to find the adjacent. So it's your division of your opposite over your tan 72, which is 4.2. And here, using the sine ratio to find the missing lengths. So here we're trying to find the opposite first, so you can cover up the opposite, and you're doing sine 29 times 12.6, which is 6.1, 16.3. And then here we're trying to find the hypotenuse, look, because opposite the right angle. So you've got the opposite and you've got the sine angle. So if you're trying to find the hypotenuse, it's 9 divided by sine 30, which is 18. And then this last one is 10.9. Okay, so here you're given the adjacent and the hypotenuse. You're trying to find the hypotenuse, so it's adjacent divided by cos angle. So 7 divided by cos 46 is 10.1. Then we've got 4.6, 2.9 and 10.7. Okay, if you've got lots of these wrong, you need to go back and watch the teacher examples again, please, or make the use of the Hegarty task that's been set for you and have a watch of his video. Okay, you're now going to have a look at these. Now they look similar to the ones we've just done, except you aren't told which ratio to use, which triangle to use, so you have to work it out for yourself. But again, they should be written in your book, but I can write them again up here. So for each one, I would like you to label the triangle. So draw these triangles, label them, pick which trigonometric ratio you have to do, okay, and then use it correctly using your calculator. And it says here round to 3 significant figures. Okay, so just be careful with that. Please pause the video as you work through these problems. Good, so we should have 12.6. I've done it to 1 decimal place actually, so apologies for that, just keep an eye on that. 4.3, 3.9, 17.1, 25.5 and 26.4, so it's just those two, the yellow and the dark green one, where your answer might be slightly different because I've done it to 1 decimal place, okay, but you'll be able to tell from looking, that shouldn't be a problem. Well done. Again, if you're not sure about these, we can just recap quickly, just to check. So we know that that A is the opposite side, and we know it's the hypotenuse, so we know we're using sine. You should have gone, well, that's the hypotenuse opposite the right angle. This one here is the adjacent, so I was using ka, and then I've got the opposite and the adjacent, so it was toa, and then here I've got the hypotenuse and the adjacent, so look, it's ka, and then I've got the opposite and the adjacent, so it's toa, and then I've got the hypotenuse and the opposite, the hypotenuse there, miss, don't be silly, and the opposite here, so it's sine. And that's why it's so important, that's why at the start we spent quite a bit of time practicing labelling the triangles, because if you can't label them, if you don't know what the sides are, you can't use the trigonometric ratios, okay? Right, we're going to have a look at a couple of problem solving questions where they're in a more real life context, and then you'll have a go at a couple yourself. So calculate the missing side. What is the height of the tree? Well, you should be able to work out that the height of the tree is this side here. Okay, now the first thing I would do is label the sides. So we're trying to find the height, so let's call it x. So we know we're given the opposite because it's opposite the 16-degree angle, and we know that this side here is the hypotenuse because it's opposite the right angle, so I must have the adjacent here. So I've got to find the trigonometric ratio with the adjacent and the opposite. Well, which one is that? It's this one here. It's toa, okay? So we know we're using tan. Now, because I was looking for the adjacent, I could maybe cross that out or cover it up, and I know I'm doing opposite over tan angle. So my opposite is 14, which you can see here, look. And my angle, my tan angle here is 16, and then to 1 decimal place, I get 48.8. So it's actually the same challenges we've been facing already with finding missing sides using trig, but it's just in more real life context, and it's rather than just having the height labelled for you, it's working out what the height is. Okay, and we know that the height and the base of a triangle are at a right angle. Right, if you could have a go at this problem, please pause the video as you do this. Right, good. So 57 inches from the base of a building, 57 feet for 57 feet from the base of a building, you need to look up at a 55-degree angle to see the top of a building. Again, what is the height of the building? So what you're looking for here is this side. So we're looking to find that, okay? So let's label. We know this is the opposite now, because it's opposite the given angle. We know that's the hypotenuse, so we've got the adjacent and the opposite. All right, so the adjacent, the opposite is our tan again, but because we're trying to find the opposite, we're doing a multiplication, look. So we're doing tan angle times adjacent. Okay, so that's what we're doing, and that dot there actually means multiply. You get 81.4 feet. Okay, brilliant. Right, a more complex one, so I'll do this one first. A boat is approaching a cliff with a light on top. The cliff is 100 metres high, we can see that here, and the lighthouse is 30 metres tall. The angle of elevation, so if you're looking up from the boat to the top of the lighthouse, is 20 degrees. Calculate the distance of the boat to the base of the cliff. So the first thing we're looking for is, well, which part are we looking for? Okay, so if we're calculating the distance of the boat to the base of the cliff, this is what we're looking for. We're looking for this side here. Okay, so now we can work out which trig ratio we're doing by labelling the sides. So that's our angle given, okay, 20. Opposite is here. So this one, if that's the right angle, because it's meeting the height, we know that's the hypotenuse, so I've got the adjacent here. Okay, so we know we're doing something that involves opposite and adjacent, and we should know that's toa. Now, if we're looking for the adjacent, well, we can get rid of him or we can put something around him, that's what we're trying to find, so we're using these two. So we're doing the opposite over the tan angle. Now the opposite is a combination, this side, look, if we draw a straight line down here, is the total height of the cliff and the lighthouse. So we need to do 100 plus 30, which is 130 metres, which gets our total opposite. Okay, so we're actually doing 130 over tan 20. Okay, and if we do that, we get 357.172, which is maybe around 357.17 because it's in metres and centimetres. Okay, lovely. Feel free to pause the video and copy this down if you'd like to. Okay, and now have a go at this question for me. Please pause the video as you do this. Right, good. A boy is flying a kite. There he is. Without holding it, that's good. The string is held 80 centimetres above the ground, so we can see that here. The kite is on a string which is 8 metres long. There we go. The string makes an angle of 80 degrees with the horizontal. So there it is, okay? Calculate the height of the kite above the ground. So what we're trying to find is this here, okay? That's the height, and that's also the height. So we already know that's 80 centimetres. Okay, we're trying to find this. So this here is our triangle. Okay, so we look at what we're trying to find, so that's the opposite. Okay, because opposite the given angle, there's our right angle, so it's the hypotenuse. So we're looking for the ratio where we use opposite and hypotenuse, and it's SO. Okay, so if we're trying to find the opposite, it is sine 30 times the hypotenuse. Now, sine 30 times the hypotenuse of 8 gets you 4, okay? So we know this distance here is 4 metres, but we want the total distance of the kite to the ground, so you have to do 4 metres plus 80 centimetres, which gets you 4.8. Brilliant. Right, really well done. If you could have a go at Hegarty task 509, which further looks at calculating sides, so myself, Mr. Sleeth, or Mr. Hayes can see how you're getting on, and that'd be greatly appreciated. Well done.